Hey WS Matrix folks. Today, we'll tackle overfitting in machine learning, and by the end, you'll know how to overcome it like a pro. Let's go. So, first off, what's overfitting? In machine learning, we train models to recognize patterns in data. Overfitting happens when a model learns the training data too well and starts picking up noise, making it perform poorly on new, unseen data. It's like cramming for an exam but forgetting everything the moment you see a question you haven't encountered before. Not cool, right? Now, how do we fix it? There are several ways, and we'll discuss some of them, along with specific algorithms, optimizers, and loss functions. Buckle up. Regularization. This technique adds a penalty to the loss function, forcing the model to learn a simpler, more generalizable representation of the data. You've got L1 and L2 regularization, and they're used in linear regression, logistic regression, and neural networks. L1 adds the absolute value of the weights to the loss function, while L2 uses the square of the weights. The choice depends on your problem and preference, but both help combat overfitting. Early stopping. This one's for the neural network fans out there. As you train your model, you'll monitor its performance on a validation set. When the validation error starts increasing, you stop the training, as this is a sign that your model is beginning to overfit. It's simple but effective. Dropout. Another technique for neural networks. Dropout randomly drops out, hence the name, a certain percentage of neurons during training. By doing this, you prevent the model from relying too heavily on specific neurons, encouraging it to learn a more robust representation of the data. Data augmentation. This one's particularly useful for image classification. You can create new training samples by applying transformations like rotation, scaling, or flipping to your existing data. This helps the model generalize better and reduces overfitting. Cross-validation. By dividing your data into multiple subsets, you can train and evaluate your model on different combinations of these subsets. This gives you a better idea of how your model is performing and helps you tune hyperparameters to avoid overfitting. Pruning. For decision trees, you can use pruning to remove branches that don't add much predictive power. This helps create a simpler, more generalizable model. Now, let's talk optimizers and loss functions. Optimizers like Atom, RMSprop, and SGD with momentum can help you find a better balance between underfitting and overfitting. You'll need to experiment with learning rates and other hyperparameters to get the best results. As for loss functions, it's important to choose the right one for your problem. For example, using mean-squared error for regression or cross-entropy for classification can help your model learn the optimal patterns in the data. But remember, always combine your loss function with regularization techniques to minimize overfitting. And that's a wrap, WS Matrix Squad. Remember, overfitting is a common issue in machine learning, but with the right techniques, you can conquer it and build models that are ready to face the real world. If you enjoyed this video, smash that like button and subscribe for more mind-blowing content. See you next time.